Good evening. My name is Ono Purbo. Uh, Thank you very much for allowing me to share some of our work at Open University. The current work is basically a collaboration approach with friends at Open University. It's around a proposed e-learning offline solution for rural and villages. So it is a collaboration approach with friends at Open University such as Profesor Daryono, Profesor Mawatoha, Pak Dikinian, Pak Mustari, Pak Randy Mateas, Pak Nurazmi Prasetyo. We are currently collaborate to build an internet offline solution for e-learning process in rural and villages. Why we need an offline solution, e-learning offline solution for rural and villages? Is for very simple reason. If we look at the data at npref.com, they provide the network coverage data for many parts of the world, including Indonesia. We can select the operator. At this moment, I use Telkomsel. We can examine the coverage of Telkomsel coverage in Indonesia right now. As we can see, it's very clearly, especially the east part of Indonesia is not well covered by cellular network. Many of the island is not covered by cellular network. In Java Island, it's looks like covered. If we zoom into the south part, so we zoom into the south part of Java Island, it clearly shows that the south part is not well covered. In the north part, looks like covered, but if we zoom in more closely, again, Jakarta is covered, but of course it's the capital city. But if you look south of Jakarta, in Bogor area, in Lewiliang, Jasinga, many of this area is not well covered. So we desperately need solution, especially for student, for uh, open university student, primary school student, high school student, to be able to have an online access to the knowledge and e-learning and so on. Well, online without internet, so it's online but offline, offline online network basically. Okay, so our solution is very simple basically. So we write a books. We are currently in process in writing books on internet offline solution. Okay, this is the book draft we upload into our Google Drive, and we collaborate in writing this book with friends at University of Open University. So this is the why we actually uh, do this kind of research, and the system is very simple actually. So to be able to have access to the knowledge offline, the e-learning offline, the books offline, and so on, basically we just copy all the content we need, the learning content, the books, video, audio, whatever content we need. We copy the content into SD card or hard drive or local storage here. So we just copy, and then so basically we need a team to make decision which content is appropriate for the students. Okay, we cannot copy all the content, but we need to decide because we also limited by the size of the content, and then this drive can be put into local server like this. Okay, so again, we need a team, person who run this local server. This local server can be put in local school or local uh, uh, office of the municipal office or whatever, and then the student can access remotely using local Wi-Fi to this local server. This local server can be built, can be based on embedded computer such as Raspberry Pi or Orange Pi, or at Open University we tried Bricks. It's a mini PC which is larger than Raspberry Pi. Of course, it can hold more content, and it can be accessed by more students. So we can always use the small ones or Bricks, which is the larger one, mini PC. The one we look at the picture is Raspberry Pi, like this. It's very small, palm size server. Bricks is much larger, uh, like looks like this. Okay, this is the one we are using right now. Okay, for server at local content. It is still affordable, of course, depending on the drive and memory we put into the system. So the price is increased by the size of hard drives we put into the system or RAM into the system. So basically, it's quite affordable as a server, and it's very small size. It's little bit larger than Raspberry Pi, but still very small for a server. Okay, so this is the size we are looking at. Okay, now uh, we we actually have to build the we have to expand the system so that the student can access the system from their houses. So the original system is very local, so we can have the local server at school or municipal office, and we put a local hotspot so student locally can access the system. But if we want the student can access from their houses, we can extend the network using long range Wi-Fi connection, which is affordable as well, to the student houses. So all of this will be covered by the books that we are currently writing, and also the the those who wants to get certified on building these things, uh, they can access through online learning. So we have books and online course on internet offline, online course in on internet offline. Very confusing. So those who wants to access the online learning for internet access online can access through this online course as well. It is currently at my institute, Institute Teknologi Tangerang Selatan. But after this finish, we will copy to Open University web server, so many people in Indonesia can access the training process online through Open University web server. The content will cover on design process of the server, the network, how to configure and install the server, the network, as well as both for PC like Bricks or Raspberry Pi, which is not far. It's fairly similar, a bit different in architecture, but it's fairly similar basically. How to create the content, install and configuration of the wireless access, some of case study, how to manage the electricity, as well as the business process. Okay, the business process will cover for how to provide services for the surrounding communities, people. For example, the server can hold some of the ebooks for primary school, high school, so those students in this school can access the system as well if you like. And also we provide some quite detailed business process for students, business process for teachers and lecturer, how to build the question bank, how to build the content so it can access locally without internet, as well as the business process for local admin who manage the server locally, especially how to get the mark from the server, the exam quiz result from the student, so the admin can then send it to the teacher or the lecturer at Open University. The last is the business process for the system developer. They have to very detail building the system. We are having a lot of challenge when we try to restore many of the Open University courses, which is on the Moodle e-learning system, into the internet offline Moodle system. So the e-learning content management system, we use Moodle, which is free, open source. We can download from moodle.org, the same Moodle used by the Open University. So this particular Moodle, we put it in the local server for internet offline. In addition to Moodle, we also use Kiwix. Kiwix like this is basically an open source browser or server that can provide or deliver Wikipedia offline. So we can copy Wikipedia, the online version of Wikipedia, put it into Kiwix and becoming an offline Wikipedia, which is very beneficial for many of the students locally. So we can basically copy of the content from web server like Wikipedia, Gutenberg project, Tech Talks, using Kiwix locally. So this is what we also install into the internet offline server. In addition to that, we also write how to web copy many websites to local internet offline server, so it can be e-learning content, Wikipedia, books, PDF, for especially for primary school and high school. Lots of books from the Ministry of Education. We copy those books into the server, and as well as Kiwix. Now, for the last section, I like to show you how to design the network. So the student, these are the GPS coordinate for the students. This is a real students from the Open University in Jasinga area, which is 2 hours, 1 hour from Bogor, which is south of Jakarta. This is south of Jakarta, but the signal is so bad. So they are having problem to access the e-learning content in the internet. We have several options to put the server, the internet offline server, either in junior high school, state junior high school number 2 in Jasinga, or state primary high school Jasinga number 1, or state primary high school Sukamana number 3. These are the coordinate of the schools. For example, we use the primary sorry. For example, we use the junior high school, state junior high school number 2 of Jasinga, and we can put it into link ui.com to design the network. It is free from ui.com, so we can put the coordinate of the junior high school, and then we can select add point to multi-point network here. Okay, so show the blue part is the signals. The one without blue is blank spot basically. So this is the state junior high school number 2 Jasinga, and we replace the antenna at the high school. This is a sectoral network. We change into omnidirectional network, and change also the frequency to 2.4 gigahertz, which is more affordable for many of the students to access. Okay, so this is the coverage if we use omnidirectional antenna. Now, to check the connection for each student, we need to put the coordinate of the student one by one to this one. So for example, this is student number one. Okay, it's yellow, it's green, so it's okay. And then this is the student number two. Coordinate. It's sorry. Oh, I have to change. Why it doesn't change? Oops. Okay. Okay. Okay, let me change into different student then. Okay. Oh, we have a faraway student now here. Let me extend the network. So we have some problem here. The connection, yes, it can reach the student, but the connection is not that perfect. What we need in this case, we need to increase the uh, antenna tower. Right now we use 12 meters and we can increase to 20 meter and it's becoming green now connection. So the connection is okay to this particular student. The distance is about 5.15 kilometers. So around 5 kilometers from the server location, and it's still connected. The speed is slower, is about 92 megabit per second at 5 kilometer distance. So we are looking at this kind of connection and speed from the student houses to the server. What kind of equipment we use at the server? We use this kind of equipment, bullet, which is about 100 US dollar, about, well, less than 100 actually. And we use omnidirectional antenna, which is around like what, $50. So we have this kind of connection at the server side. At the student side, we can use a cheap walkbolic, wajan bolik, which is walkbolic. It's something like this. And also many people sell this walkbolic for $30, $17, $16. It's very cheap. So the student can connect from their houses using this kind of connection. We just put this walkbolic on a pipe, and then we have a connection. That's it. Very simple as that. So we really hope this kind of solution can be accessed online from the e-learning or from the books, and hopefully many schools in Indonesia, including the Open University students, can access the knowledge without having to problem with the cellular infrastructure. So they can access the knowledge without having to pay for the cellular infrastructure, and they can connect 24 hours to the content because the content is now becoming local. Okay, so it's called internet offline, and it is our hope the internet offline can provide solution for the Indonesians, so they can learn, they can strive, and they can survive in the next decades. Thank you very much.